Hello and welcome. My name is Alastair Browne, and I have been a space advocate all my life. I attended the University of North Dakota, where I earned a master's degree in space studies. I write about space development, and I have a newsletter simply called Alastair on Space Development, and you can find this on LinkedIn. I have also given presentations on space development at conferences such as the International Space Development Conference, sponsored by the National Space Society. I have co-written a book along with Marianne Corinch called Cosmic Careers, and it has been released worldwide. This is the book. It covers space exploration and development, past, present, and future, but it mostly covers the book and work that will be done in space and on the ground related to space. This is the true theme of the book. Not only does it cover professional jobs for astronauts and engineers, but common everyday jobs and skills here on Earth that will be needed up there, though nobody knows that yet. There are jobs like interior decoration, sewing, construction, medicine, agriculture. It's all there and more. Any skill that any person has will be needed in space. Note on the slide is the book and the address provided by clicking it. Now here you can order the copy of the book for yourself. If you notice a QR code, you can pause this frame and scan the code, and it will take you to the podcast of this book. This podcast, simply called Cosmic Careers, covers the entire book, one podcast per chapter, and it is discussed by both Veronica Chiaravalli and myself. See for yourself, listen to my podcast, and buy the book. You won't regret it. One podcast covers what I will talk about today. Today, I will give a presentation on building an independent lunar society. I will cover what is required to undertake such a task and how it will be done and how it will benefit all of society, both on Earth and in space. Lunar society begins with building a lunar base. Now, this would be a self-supporting lunar base, and it must have three different functions: scientific investigation of the moon and its environment, development of lunar resources for space-based industries, and developing a self-sufficient lunar settlement, which is the primary option or objective when it comes to settling the moon. But you can't have one without the other two, because all three are interdependent upon one another. Now, building a settlement, scientific research, and development of lunar resources are all, as I said, interdependent, and they intersperse with each other. With settlement, you have lunar shelter, agriculture, water power, air to breathe, protection from radiation. Science, you have to research all of these. Research and development for agriculture, power systems and medicines, that's for the scientists to do, and workers to develop the lunar resources, to build shelters, and later develop these resources into building products. But that will come later. First, of course, you have to settle the moon. And settling it, not only building the shelter, but exploring the moon for other resources and processing these lunar resources, and eventually developing advanced machinery. Here is a lunar base in all its function. Now, the first practical experience would be adopting to life on another planetary body. It would be first demonstrations of humanity's abilities to alter the environment through use of native materials, living off the land, and then developing the infrastructure to tap natural resources of space to create profitable enterprises. Here, what we need in settling up a base is obviously construction equipment. You have to bring that along to build your lunar shelter. A lot of these materials are going to be from cargo landers. With the lunar shelter technology, you have to have water sources, food production, oxygen, and lunar power stations for electricity, and all of this must be developed simultaneously. For lunar habitats, they can be taken from ISS technology, taking nodes from the International Space Station. You can take them from spent rocket stages left in Earth orbit to be towed and softly landed on the moon, and there are plenty of those right now known as space junk, but they can be put to good use. And of course, they would have to be refurbished and they would have to be covered with lunar soil about 2 to 4 meters to protect from solar and cosmic radiation and solar flares. An interior of these habitats would contain proper facilities needed for living, and they can also be decorated for the inhabitants' pleasure. And interior decorators would come in. Here are nodes, the International Space Station. Note that this is done by artificial intelligence. These pictures here, you're not going to find them perfect. You're going to find two planets in the sky. But this is the only thing I could do without taking other pictures from other people and violate copyright laws. This is for my own protection, just to let you know in advance. So you'll see a lot of illustrations. They might not be the right way, but that's all I can do with artificial intelligence. And if AI is like that, I don't think we have that much to worry about with AI, in my opinion. And here is another lunar settlement. Sources of water on the moon. Hydrogen can come from hydroxyls found in the lunar soils. It's rare on the moon. Or there are water-bound molecules in these rocks, and they can be extracted and used to produce energy. Near-Earth asteroids are composed of ice. Crash an asteroid on the moon, although I'm a little reluctant to do that, because that could cause a lot of damage if it's too close to a settlement. Or mine an asteroid of ice in space, melt the ice, and transfer the water to space tankers and gently land it on the moon. But there's been a third possibility. A lunar prospector, and Clementine, has found water ice permanently shadowed in these areas. And they are in shadowed areas at 170 degrees below 0 Celsius, and at night it's a lot colder. It's been found at the poles. It's been theorized that 22% of Shackleton crater is covered with water ice, with a total mass on the moon of 6.6 billion tons. I would like to add here that South Korea recently launched a probe called Danuri, Danuri, and NASA provided ShadowCam, which is 200 times more efficient in sensitivity than the Lunar Prospector. And what Lunar Prospector only detects in the dark, ShadowCam can bring it to light. Now, the images have only shown white spots. There have been water detected, maybe not as much, but water is at least still there. So we have to take with what we got. We'll find out everything when we do land on the moon. But as for now, accept 6.6 trillion kilograms. Here is supposedly an ice station on the moon at Shackleton crater. Now, these are all of these are assumptions, but what is true that water and hydrogen and oxygen do exist on the moon and is accessible to those who established settlements, which is water for drinking and agriculture, water for rocket fuel. They say we can provide gas stations for rockets that run on hydrogen and oxygen. But here's another ice station on the moon. But I would like to point out this should only be temporary, because even though there's an estimate, when it's used for rocket fuel, mixing hydrogen and oxygen, producing a propellant and propulsion, once it's used, it's gone. It can't be recycled. So it can only be used temporarily until we develop better propulsion systems. Before that, for food, we must import all food from Earth and other space stations. But the moon, the lunar regolith, has a lot of resources and oxygen locked in it. If we remove the oxygen and the resources, we'll have plenty of lunar soil left. We'll process it, mix it with human waste, plant waste, and we'll produce good soil to grow plants. And this can increase as time comes. We set up a greenhouse to grow a large variety of crops. Animals will be added for meat, small animals, but eventually sheep and goats. Eventually, set up a huge plot of land, install a glass dome to cover it. And when I say glass, I mean lunar glass. And it'll be a lot stronger than any glass made on Earth. I'll discuss that later. We may either bury it deep for the foundations, or put a floor at the very bottom and add it with processed soil. And we build mini farms as the population increases. Here are some lunar farms right there. Notice the glass domes. Here's another glass dome with sort of like a forest and a park. To produce oxygen, here are raw materials in the lunar soil containing the oxygen: silicon, iron, sodium, chromium, to name a few. You see the whole list there. If we remove the oxygen, which is very easy to do, and then separate the minerals from the lunar regolith, you'll have pure soil. And we use the minerals and the oxygen, of course. Nothing gets thrown away. So once we extract them using techniques, here is a few methods of oxygen extraction. Ilmenite, I'm going to just go over this briefly, where you put in liquid hydrogen with some of the elements in the soil. It would mix, separate the oxygen. You'd have hydrogen and oxygen still left over, water, and then put the hydrogen back, and then you could do it all over again, an infinite loop. The second would be using carbon, which you can get by burning garbage. Here's dissolving ilmenite or sulfuric acid, and that would definitely separate the minerals from the soil and the oxygen, or gases such as methane will do the same thing. These are all chemical reactions, incidentally, and there are a lot more ways than this to process the soil. I've just shown you 4. And here is a mining station. Notice all these vehicles about to receive their orders about where to mine the lunar regolith. And incidentally, mining the moon would not be like mining the Earth, digging pits to find clumps of minerals like we have in iron, gold mines, because they're all mixed and they're all found in the lunar regolith. All we have to do is take lunar regolith from the surface. An easy chore to do. So for now, eventually as we go deeper, you may find clumps of lunar soil, clumps of minerals. But as of now, it's not going to be that big of a challenge. Here's for electricity, for power, we got 3 reliable sources: solar power, lunar oxygen and hydrogen, and nuclear fission, a constant power source day or night. But since we're going to settle on the moon, we're not going to use nuclear power at first. We will be using solar energy, and if you think solar energy is powerful down here, it'll be a lot more powerful up there. Or you will use the process of fuel cells. Hydrogen and oxygen can produce a lot of energy through fuel cells. Here is a nuclear power station. They will come. And it is said in Mare Frigoris that thorium, there has a huge supply of thorium that can be used for a fuel, but they're trying to develop it. And I've just read that China right now is trying to build a reactor that runs on thorium. But for present power plants, it'll be solar power during the day, fuel cells at night. Nuclear power will come later. Later facilities, mining facilities, and a lunar regolith processing plant. We've discussed that. You could use the minerals after we've processed a regolith for lunar manufacturing, making small products before we go on to the big. And as we construct this space, we will focus on human factors and relationships. That's very important. Health and medicine, making clinics and having doctors. Economic trade system. You have to pay for this moon base itself. It cannot be supported for a long period of time by taxation. It has to be self-supporting, and an expanding population base. More people will want to come to the moon to settle. For health and medicine, humans will have to adopt to 1/6 of the gravity. How will they handle illnesses or accidents? Doctors and a clinic, at least. And medicines made in low or 0 gravity, which will be much better than on Earth. And many of these things I mentioned are material for separate lectures. In a psychological environment, it's closed. Stress and adjusting to a 2-week day-night cycle. Some people would love it. Some people can't handle it at all. Here is sort of like a kitchen or recreational area with a picture of the moon and space outside. And so the moon will have a beauty of its own. Further expansion of the base, being independent of Earth, that's the idea. Expansion of all lunar facilities, advanced space facilities, which we will manufacture in due time. We have to start from the bottom, and this will be the beginning of an export economy. So not only will the moon pay for itself, it'll make a huge profit, and this will lead to lunar industry, building an industrial base. It'll make it self-supporting, using lunar resources, developing these resources, and developing an independent economic system. I keep saying this, I know, but that has to be stressed. Now, the following can be helped to establish a solid lunar base. Manufacturing facilities, of course, but these would have to come from minerals and lunar oxygen, which these two will have to come from lunar regolith, and regolith will be also used for radiation shielding. So just the lunar regolith itself will be a gold mine. And among this, private companies will want to participate now that they know they can make a lot of money from it. Don't forget, these industries will not invest unless they know there's a profit to be made. But once they see that there is a profit to be made, they'll line right up. The steel industries, mining, energy corporations, and the construction industries and aerospace industries, making spaceships on the moon or in space. And the government and the corporations, of course, will want their share of the profits if and when they are turned, which they will be. Lunar concrete, that and helium-3. Lunar concrete can be crushed to a source, mixed with cement paste, and then can provide a sealant for many of these lunar habitats away from the vacuum. It can really protect from radiation in space, cosmic, lunar, and solar. It's strong in compression, and it'll be stronger than any type of concrete made on Earth, which means if it gets exported to Earth, the concrete industries are going to get a run for their money. Who knows? They may even want to invest in lunar concrete themselves. Here is another lunar manufacturing facility. And lunar concrete, if it's the energy and ratio between aluminum, alloy, and concrete is 90-1, saving massive energy costs. You can shape concrete as you can now. It'll have greater strength, greater heat resistance, radiation shielding, and it'll be protected from micrometeorites. They can just keep raining on shelters made of lunar concrete, and the hardness of it will protect the people or the inside. So water will be required, of course, to make it, but it will come from the moon itself. And I've told you about exporting it to Earth and what would happen. And here are a couple of habitats covered with lunar concrete, supposedly. Lunar glass will also be harder than any Earth glass. Combine it with elements on Earth, the glass weakens the material, but the absence of water on the moon, along with vacuum, makes the lunar glass extremely high in strength. With an effort in processing, glass can be separated from the lunar soil to form fibers, tubes, rods, giant slabs for giant windows on O'Neill space colonies, and domes to cover farms, even cities. We've discussed that. Here is a dome covering a farm on the surface of the moon. It'll be a lot stronger than glass on Earth for reasons I've already stated. And helium-3 is the last of the minerals, and that would be more valuable than gold. You can skim it from the surface of the moon. It comes from solar and cosmic rays bombarding the moon. It is replenishable, so it'll be almost impossible to be depleted. Now, they say it's good for fusion, but nuclear fusion is not yet possible. Now, helium-3 in fusion can generate a lot of energy with no nuclear wastes. Probably the best form of nuclear fusion possible, but since that is not now available, you can use it for other purposes today, such as medical imaging and 3D for more precise operations. And this is what I like, detecting nuclear material, such as a bomb in a suitcase in an airport, to prevent nuclear terrorism. So there is a way to fight terrorists carrying a suitcase bomb. Cryogenics, putting people and animals in hibernation to slow down their metabolism, putting them in suspended animation for 2 weeks. And I'd like to tell you, this has been done. And the time can be expanded for more advanced forms of space travel. And so here are another list of the minerals that the moon can provide just from the lunar regolith. And I'm adding usable amounts of nickel iron alloy, which are also found in asteroids. Here is another lunar ice station base. Trace elements, hydrogen, which we need for reasons I've stated, to mix with oxygen to form water. And here are other forms to produce water, oxygen, fatty acids, vitamins, and sugars. It doesn't seem that way with the type of elements that we have, but they are very, very important. Platinum group metals. They are found in lunar soil, rare, but they're valuable when obtained. One for making jewelry, but not only making jewelry, which is a luxury, but also making computers, computer chips, fuel cells to produce power, and solar panels, solar cells. And this is one of the futures of alternative energy right here. Again, another mining station. So we set up a pilot plant to mine these minerals and make small components such as silicon chips, photovoltaic cells, glass, chemicals, medicines, alloys, superconductors. We'd have to start small, of course, but then these factories, as we produce more of them, they would grow and we would build bigger products. All right, another lunar base right here. To summarize, lunar resources offer vast opportunities for up-and-coming industry, for anyone willing to make the investment. There will always be risks. Scientific researchers, I'll just go over this briefly, but this is just as important, probably the most important, because whenever you set up anything on the moon, whether it's agriculture, building lunar habitats, or materials processing, or using minerals for product manufacturing, you're always going to want to have better ways of doing things. And this is where science and resources come in. You're going to need research and development in everything. And the advantage that the moon has, low gravity, a planetary magnetic field, access to a planetary environment, no atmosphere, just the whole space environment to experiment with. It's all right there. Here is a radio telescope on the far side of the moon to detect radio signals from way out in the universe. Life sciences and ecosystem studies. How do biological animals and plants function in 1/6 gravity? And that includes human being. How do we function when we're sick? Healthcare, recycling, which we will do on the moon. And when we do that, I hope it spins off on Earth for more advanced methods. And all this will be a good practice for a mission to Mars. Materials processing. Again, testing for density, shear strength, thermal conductivity, and electrical properties. And with the environment of space, these will all be advanced from anything that you can make on Earth. Conclusions, technological developments, long-range surface transportation, communications, and construction and assembly of large instruments. We'll start slow, but it will speed up as we all get used to the new environment. And this is an independent lunar settlement. There are benefits to Earth from lunar development, having beneficial effects on Earth society. There are many other benefits to space, as well as to the people of Earth. Not everything has been covered in this presentation, but not everything can be. You'd have to write a whole book about that, possibly even a library. But as we develop the moon and its resources, it'll demonstrate that human civilization has no limits to growth. Frontiers, energy, and materials resources are unlimited. All this will result in improved living standards for the people of Earth. More jobs, more business opportunities, low-cost access to vast material and energy resources, and advanced recycling methods. All of these I have covered. In fact, all of these were the main ideas in this presentation. But the quality of life will improve for the people of Earth. Reduce pollution through decreased means of drilling and mining, make the Earth into a park and putting many polluting booming industries in space or on the moon, low-cost energy, migration potential, although I'll point out that very few people, only a low percentage of the Earth's population will ever migrate to space. But since this will be a pressure valve nonetheless, the valve will be there. The option will be there for anyone. Enhancement of international cooperation instead of competition, which means if we cooperate with enemy countries in space or on the moon with countries like China or North Korea, we'd have to get along on Earth, and I'm sure ways will be found to do so. So this could advance ways to make Earth a more peaceful place to live, access to engineering advances, more resources available to more of Earth's population. So instead of dividing the pie into smaller pieces, we make the pie bigger, so there'll be more for everyone. So it'll be at this point in time with advanced life support systems, propulsion systems, and constructing a base, and psychological and physiological factors that we will proceed to a mission to Mars. Once we got the moon down, the Mars will be a piece of cake. And this has been brought to you by my book, Cosmic Careers. I have mentioned some of the job opportunities in space and on the moon that are mentioned in this book. However, many other jobs are mentioned. Cosmic Careers, you'll find that space has something for everyone, no matter what your skill. And I recommend that you order this book. Go look at the address online at the very bottom, and you can just click it. You'll be able to order my book, and it's going at a very, very cheap rate. You can afford it. And thank you. My name is Alastair Browne. I have a Master of Science degree in Space Studies, and my company is Storm Browne Enterprises. Here's all the info. If you want to just freeze your frame and copy all the info, you are free to do so. And you can even contact me if you want a conversation. I am open anytime. And you can order a copy of my book. Here's another address for my book, Cosmic Careers. For further consultation, you can go to this. It'll send you a form and we can fill it out. Very easy to do. Click send. I will receive it. And if you want, we can arrange an appointment on Calendly with a link and we can have a chat. I'm very, very open to all of you, and I hope I will get to speak to some of you. The end of this presentation and the beginning of our new adventure. Goodbye and good luck.